Hello everyone, welcome to the next session of ANSYS Workbench tutorials. In this session, we are solving another problem of SF and BM plotting in ANSYS Workbench. This is the problem that we are solving. AB is a cantilever beam. There is UDL on the cantilever beam. A to C has UDL on it, and DB portion also has UDL on it of 2 kN per meter each. And at points C and D also there are two more point loads that we can see. They are of 4 kN each again. So let's start solving this numerical on ANSYS. I'll double click on static structural. I'll rename the file as SF BM example 6. I'll go to geometry, right click, new design modular geometry. I'll go to XY, look at. I'll go to sketching. I'll draw the first line, which is my first part of the beam, that is A to C. I will give it dimensions. The length is 4 meter. Then I'll draw the rest two part of the beam, that is CD and DB. I will give them dimensions as well. H2 is 2 meter and H3 is 4 meter. I'll go to concept, lines from sketches. I'll select the sketch, apply, generate. Next I'll go to concept, cross section, rectangular. I'll give it some dimension. I'll go to one part, one body, line body. I'll choose the cross section just made. I'll go to view, cross section, solids. So this is how it looks like. This is a very simple geometry that we have created looking at the problem. Next we'll go to model and double click on it. I'll go to model and construction geometry. I'll choose path. I'll change path type to edge and I will select the beam. I'll use edge option, select the first part of the beam, then I'll press the control button and select the rest two part, apply. I'll go to mesh. I change the sizing to fine, update. Next I'll go to static structural. I'll choose point at end A. It is fixed. At point C there is a force in the downward direction. I'll change vector to component. Along the y-axis the load is 4 kN, so it is 4000 Newton. Also at point D there is a force in the downward direction of 4 kN. Next I'll apply UDL. First on AC portion of the beam, I'll insert force. I'll change vector to component. Along the y-axis, I'm going to apply the force. So if you look at the concept of UDL, you are going to multiply the load with the distance, that is 2 into 4. If you look at the diagram here, it is 2 into 4, 8 kN, and it is placed at 2 meter from end A. So at y direction, I'm going to write 8000 Newton. On this side of the beam, I'm again going to apply a force that is of UDL type. This is also 2 into 4, 8 kN, as you can see in the FBD. So along the y-axis, I'll apply 8000 Newton. Next, I'll go to solution, right click, insert deformation, directional. I want to see the deformation along the y-axis. I'll insert probe force reaction at the fixed end. I also want to see the moment reaction at the fixed end. Then I'll go for beam results, shear moment diagram. I'll choose the path that I've already created. And last, I'll go for the beam tool results. I'll solve and wait for the results. This is the directional deformation over the beam. You can animate and see the result. These values are obtained over the beam. They can also be found by clicking on this probe button and then selecting that part of the beam where I want to see the result. I want to see the force reaction in the y direction. So at end A, the value is 24 kilonewton. Let's check. Here you can see the reaction is 24 kilonewton at end A. Next, I want to see the moment reaction at end A. I will see the moment about z axis because that's how you can see the direction of moment. It is 1.2 into 10 raised to 5 Newton meter, which makes it to 120 kilonewton meter. Now let's see what I obtained here. It is 120. Next, I want to see the shear moment diagram. So this is the diagram obtained. At end A for shear force, I can see the value is 23 kilonewton. Let's check. It is 24 here. Now this is 23.857. So you can round off to 24. On the beam, I want to see at position C, that is 4 meter. So I will check here. At 4 meter, I can see there's a change in value from 16 kilonewton to 12 kilonewton. Let's check. Yes, it's absolutely correct. Next, I want to see for the position D, that is 6 meter. So let's go down to 6 meter. I can see it is 12 kilonewton to approx 8 kilonewton. So here it is. And at the last point, that is 10 meter, the value is 0. So let's check. At 10 meter, the value is approximately 0. So it's correct. Now let's check for the bending moment diagram. At end A, the value is 120 as we have just seen. And in between, the values also can be read from the table. So I will go for the diagram. At point C, that is 4 meter, I want to see the value. Here I can see it is 40 kilonewton. So let's check here. At 4 meter, the value is 40 kilonewton. It's absolutely correct. Next, I want to see at 6 meter, the value is 16 kilonewton. Let's check. Yes, it is 16. And at point B, it is 0. This is something that we already know, that the graph is going to start and end at 0. So it is approximately 0, 2.5815 into 10 raised to minus 5, which is 0. So both the solutions are giving me the same answer. I can also check for the beam tool results here, the stresses on the body. So with this, I come to know that the solution by both the methods are matching each other, and my solution by both the methods are correct because they cross-verify each other. So with this, I end the session. I hope you have understood the procedure for this numerical. If you have any doubts, please write to me in the comment section. See you in the next session. Thank you.